Hello everyone, today we're going to do another video on vapor pressure lowering. In this example, we'll talk about that both the solute, which is the one you will have less in our solution, and the solvent, the component will have more, they're both volatile. Okay, and then let's double check. In our example, we have methanol, okay, which is volatile, and also we have ethanol, both volatile. Okay, now let's keep on going. Okay, and now let's see from this question what are the information given. Okay, so for methanol, we also have that we also have the grams. Okay, and then for ethanol, we also have grams, and then we already know when we see gram, we should just automatically see it as moles. Okay, and then the moles will be by calculating using molar mass of each, and then which are given from this question. Okay, so over here we see the molar mass for methanol and then the molar mass for ethanol. Okay, so all those are the given information. Okay, and then also we're given with the substance with the pure solvent by themselves, the vapor pressure. Okay, let me just change the color of this one. Okay, so the vapor pressure for each just by themselves, and now we have a solution, and then we also know which is the equation we're supposed to apply. So the equation we're supposed to use that the total pressure of this solution will equals to the vapor pressure from the solute, because they're both volatile, and then the vapor pressure from the solvent. And how we're going to calculate each term over here. So for the solute, we're going to use the mole fraction of the solute multiplied by its pure solute vapor pressure, and then the same way we'll calculate for the solvent. So that'll be the mole fraction of the solvent multiplied by the vapor pressure. We have pure solvent solution. Okay, now the next thing is we just need to figure out how we calculate each term from these two expressions. Okay, and now with the given information, we'll be easily calculating the mole fraction of the solute and the solvent. Okay, so now let's start. Okay, so the mole fraction, now we're going to start with the mole fraction of methanol. Okay, and then in order to figure out that, we need to know the moles of each. So the moles of CH3OH methanol will be that 50 grams, and we do a conversion. 1 mole will be 32.04 grams. This gives us 1.56 moles. Same way of calculation, we'll do moles of the ethanol. 50 grams as well. 1 mole over 4607 grams gives us 1.09 mole. In this case, after this step, which one do you think is our solute? Which one is our solvent? Yeah, ethanol will be our solute. So this is our solute because we have less, and then the other one will be our solvent. Yes, that's our solvent, and now we have our system. Now let's just finish the calculation. Now we need to do the mole fractions. I'll start off from the mole fraction of the solvent. Okay, so the mole fraction of CH3OH equals to 1.56 mole, 1.56 mole plus the 1.09 mole. This is an easy calculation. Then it's going to be 0.59. This number should be always smaller than 1 because it's a fraction. Okay, and a mole fraction of the components. And then the other term we're going to do is the mole fraction of the ethanol. Same way of calculation, but instead of now it's going to be 1.09 this gives out 0.41, and these two numbers should add up to 1 because in this solution you only have these two components. Okay, so that checks out. That's good. Okay, now the next thing, we just need to use these two mole fractions and along with this given information and put into this equation, finish our calculation. Okay, so now let's see the total of this solution will equals 2 of the solute plus the vapor pressure of the solvent. Okay, and then the next step will be the mole fraction of the solute. In this case, we'll consider that will be our ethanol, so that the pure vapor pressure by itself, and then mole fraction of the solvent. Okay, now I'm just gonna plug in the numbers, so continue over here. Okay, so the total pressure of the solution now equals to 0.41 times that 45 torr plus that will be 0.59 times 92 torr, and then calculation comes out as 18.45 torr plus 54.28 torr adds up around 72.73, and in our calculation we keep in our question we keep two sig figs, so the answer is gonna be D as dog 73 torr. Okay, and this is how you do a calculation when you have both the solute and the solvent. They're both volatile, and then you need to use this equation. Okay, and that's it for this video. Thank you for watching.